Type 1 and Type 2 error, 5 marks. Introduction. Statistical errors. There are two situations in which the decision made on data in the statistics becomes wrong. They are called as the errors in statistics. Of statistical errors there are two types or statistical errors. They are Type 1 error, Type 2 error. Hypothesis test. Hypothesis test is a standard format for assessing statistical evidence. Hypothesis is a statistical method that uses sample data to evaluate hypothesis about a population. Hypothesis test examine two opposing hypothesis about a population, that is the null and alternative hypothesis. When statistical hypotheses are tested, there are four possible results. A. Accepting a null hypothesis when it is true. Null accepted. B. Rejecting a null hypothesis when it is false. Null rejected. C. Rejecting a null hypothesis when it is true. Type 1 error. Population mean is not equal to 150 even though population mean is 150. D. Accepting a null hypothesis when it is false. Type 2 error. Example: the population mean is 150 even though it is not 150. Above these results A and B are correct, whereas C and D are errors. They are respectively known as Type 1 and Type 2 error. What is error? Error or statistical error describes the difference between a value obtained from data collection process and the true value for the population. The greater the error, the less representative the data of the population. The greater the error, the less reliable are the results of the study. Researchers cannot know with certainty whether a null hypothesis is true or false based on data from a sample. They can only conclude that hypotheses are probably true for probability false, and there is always a risk of error. Researchers can make two types or statistical error: rejecting a true null hypothesis or accepting a false null hypothesis. Type 1 error, alpha error, error of the first kind. Type 1 error occurs when null hypothesis is rejected, when it should have been accepted. Type 1 error is the wrong rejection of a true null hypothesis. The rate of Type 1 error is called the Syzhov test and denoted by the Greek letter alpha. A. It is the incorrect rejection of a true null hypothesis. The Type 1 error is fixed at 5%. It means that there are about 5 chances in 100 that we will reject HO when HO it is true. Error that occurs when the researcher concludes that the sample tested are from different population. A significant difference exists between groups, when in fact, the samples are from the same population. No significant difference exists between groups. The null hypothesis is rejected when it is true. These errors occur due to unrepresentative sample drawn from the population. Rejecting a good lot, though it was correct. Example: if we conclude that a drug was more effective than in placebo in reducing cholesterol, when in fact the observed differences in cholesterol levels resulting from sampling fluctuations, we would be making Type 1 error, a false positive conclusion. Example: a test that shows a patient to have a disease when in fact the patient does not have the disease. Example: an experiment indicating that a medical treatment should cure a disease when in fact it does not. Reducing Type 1 errors. Prescriptive testing is used to increase the level of confidence, which in turn reduces Type 1 errors. The chance of making a Type 1 error are reduced by increasing the level of confidence. Or, the probability of committing Type 1 error is specified by the level of significance. If a high level of significance is selected, 0.1 or 0.2, in the statistical test, the probability of rejecting a null hypothesis increases. This means that at high significance level the chance of committing the type of error is high. Thus, in order to avoid or reduce the Type 1 error, a fairly low level of significance is selected, 0.005 or 0.001. Type 2 error, beta error, error of the second kind. The rate of the Type 2 error is denoted by the Greek letter beta. If the HO is false, it should be rejected by the test of hypothesis. If an investigator selects significance level 0.005 or 0.001, much lower than the conventional level, then the probability of rejecting a wrong null hypothesis reduces. Does the investigator is said to we committed the Type 2 error. Type 2 error is the wrong acceptance of false, wrong, hypothesis error that occurs when the researcher concludes that no significant difference exists between the samples examined when in fact or difference exist. The null hypothesis is regarded as false. Reject HO when it is true. Type 2 error occurs where null hypothesis is accepted, when it should actually have been rejected. A type 2 error occurs when one rejects the alternative hypothesis, fails to reject the null hypothesis, when the alternative hypothesis is true. This error generally occurred due to an unrepresentative sample drawn from the population. Accepting the bad lot example, if we concluded that group differences in cholesterol resulted by chance when in fact the drug did reduce cholesterol, we would be committing a type 2 error, a false negative conclusion. Example: a blood test failing to detect the disease it was designed to detect in a patient who really has the disease. Example: a fire breaking out and the fire alarm does not ring. Example: a clinical trial of a medical treatment failing to show that the treatment works when really it does. Reducing type 2 error. Descriptive testing. It is used to better describe the test condition and acceptance criteria, in which in turn reduces type 2 errors. This increases the number of times we reject the null hypothesis, with a resulting increase in the number of type 1 errors, rejecting HO when it was really true and should have not been rejected. Therefore, reducing one type of error comes at the expense of increasing the other type of error. The same means cannot reduce both types of errors simultaneously, or in order to avoid the type 2 error, very low level of significance should not be selected in the statistical test.